Since the dawn of humanity, we have gazed upon the stars with wonder and ambition. The night sky, with its twinkling stars and mysterious patterns, has always been a source of inspiration and curiosity. Ancient civilizations mapped the heavens, creating myths and legends to explain the celestial phenomena they observed. The vast expanse of space, with its countless celestial bodies, has always beckoned us to explore the unknown. From the bright glow of distant galaxies to the enigmatic black holes, the universe is filled with wonders that challenge our understanding and ignite our imagination. For centuries, science fiction has fueled our imaginations, painting vivid pictures of humans colonizing distant planets and establishing thriving interplanetary civilizations. These stories, whether in books, movies, or television shows, have inspired generations to dream of a future where humanity reaches beyond the confines of Earth. The idea of reaching out beyond Earth, of becoming a multi-planetary species, has an undeniable allure. The sight of rockets launching into the sky, astronauts floating in zero gravity, and rovers exploring the surface of Mars captures our collective imagination and fuels our desire to explore. It speaks to our innate desire for exploration, for pushing the boundaries of what's possible. Just as explorers have ventured into uncharted territories on Earth, we now look to the stars as the next frontier. The spirit of adventure and the quest for knowledge drive us to seek out new horizons. But while our dreams may soar among the stars, the reality of interstellar travel and colonization presents us with a sobering set of challenges. The vast distances between stars, the harsh conditions of space, and the need for sustainable life support systems are just a few of the obstacles we must overcome. The laws of physics, the limitations of our current technology, and the fragility of the human body all conspire to make this grand ambition a distant prospect, at least for now. Yet with each technological advancement and scientific discovery, we move one step closer to turning these dreams into reality. The vast distances between Earth and even the closest potentially habitable planets are staggering. These distances are not just numbers, they represent significant challenges in terms of time, resources, and human endurance. Consider our neighbor Mars, often touted as the most likely candidate for colonization. Mars has been the focus of numerous missions and studies, all aimed at understanding its environment and potential for supporting human life. At its closest approach, Mars is still about 34 million miles away from Earth. This distance varies as both planets orbit the Sun, sometimes making the journey even longer. That's roughly 140 times farther than the Moon. The Moon, our closest celestial neighbor, is a mere 238,855 miles away, making it relatively accessible compared to Mars. To put this into perspective, the Apollo missions, which took humans to the Moon and back, were only possible because of the Moon's relative proximity to Earth. These missions were monumental achievements, yet they only scratched the surface of space exploration. A journey to Mars, with our current technology, would take at least 6 to 8 months, exposing astronauts to prolonged weightlessness, cosmic radiation, and the psychological strain of confinement. These are not trivial challenges and require significant advancements in space travel technology and human resilience. And this is just Mars, a mere stone's throw away in cosmic terms. The vastness of space means that even our closest planetary neighbor presents formidable obstacles. Journeys to other star systems, even those relatively close to our own, would take thousands, if not millions of years, using conventional propulsion methods. The dream of interstellar travel remains a distant goal, requiring breakthroughs in physics and engineering that we have yet to achieve. Our current spacecraft are technological marvels, capable of incredible feats of precision and endurance. But they are still woefully inadequate for the task of transporting large numbers of people across the vast distances of space and safely landing them on another planet. Existing propulsion systems rely on chemical reactions that, while powerful, are highly inefficient. They require enormous amounts of fuel, making spacecraft incredibly heavy and expensive to launch. Furthermore, our understanding of the long-term effects of space travel on the human body is still incomplete. We know that prolonged exposure to microgravity can weaken bones, atrophy muscles, and disrupt cardiovascular function. But we are only beginning to scratch the surface of the potential psychological impacts of long-duration spaceflight. The harsh reality is that the human body is simply not designed for life off-planet. Our bones, muscles, and organs have evolved to function optimally under Earth's gravity and atmospheric conditions. We are creatures of Earth, evolved over millions of years to thrive in its specific environment. The air we breathe, the food we eat, and the water we drink are all perfectly suited to our biological needs. The absence of a breathable atmosphere, the lack of protection from harmful radiation, and the extremes of temperature in space pose significant threats to human survival. Space is an unforgiving environment where even the smallest mistake can be fatal. On Mars, for example, the average surface temperature is a frigid -62 degrees Celsius, or -79 degrees Fahrenheit. This extreme cold makes it incredibly challenging to maintain human life without advanced thermal protection. And the thin atmosphere offers little protection from the sun's intense radiation. This means that any human presence on Mars would require robust shielding to prevent harmful exposure. Creating self-sustaining habitats on other planets, environments that can replicate Earth's life-supporting systems, would require technological advancements that are currently beyond our reach. We would need to develop new materials and systems to create a stable and safe living environment. We would need to find ways to generate breathable air, ensuring a continuous supply of oxygen for all inhabitants, produce food, manage waste, and recycle water, creating a closed-loop system that mimics Earth's natural cycles. All while shielding ourselves from the dangers of space. The challenges are immense, but so are the possibilities for innovation and discovery. Section 5. The Mars Diaries, Lessons in Isolation and Confinement. To understand the psychological challenges of long-duration space missions, we can look to real-world examples of isolation and confinement here on Earth. Studies of researchers stationed in Antarctica during the long winter months, or of submariners living and working in the cramped confines of a submarine for months on end, provide valuable insights into the psychological stresses of prolonged isolation, confinement, and sensory deprivation. These studies have shown that such conditions can lead to a range of psychological effects, including depression, anxiety, mood swings, and interpersonal conflicts. These psychological risks would be magnified exponentially during a multi-year mission to Mars, where communication delays, limited privacy, and the constant threat of equipment failure would add to the stress. Section 6. Cosmic Radiation, an Invisible Threat. One of the most significant yet often overlooked challenges of space travel is the constant bombardment of cosmic radiation. Unlike on Earth, where our atmosphere and magnetic field provide protection, astronauts in space are exposed to high levels of radiation from the sun and other cosmic sources. This radiation can damage DNA, increasing the risk of cancer and other health problems. Current spacecraft offer limited shielding from cosmic radiation, and developing effective countermeasures is a major focus of ongoing research. Until we can find ways to significantly reduce or eliminate the risks posed by radiation, long-duration space missions, let alone colonization, will remain a dangerous proposition. Section 7. The Cost of Dreams, Funding, the Final Frontier. The immense financial resources required for space exploration and colonization present another substantial hurdle. Developing new technologies, building and launching spacecraft, and supporting human life in the harsh environment of space are all incredibly expensive endeavors. The Apollo missions, for example, cost the United States an estimated $257 billion in today's dollars. While space exploration offers numerous scientific and technological spin-offs, securing the necessary funding for large-scale projects like planetary colonization would require a sustained commitment from governments and private investors, a commitment that may be difficult to maintain in the face of pressing terrestrial concerns. Section 8. The Ethical Quandary: Interplanetary Contamination. Beyond the scientific and technological challenges, the prospect of colonizing other planets also raises important ethical considerations. One of the most pressing concerns is the potential for interplanetary contamination. We know that life in some form exists on Earth, but we don't yet know if life exists elsewhere in the solar system or beyond. Sending humans to other planets, even with the most stringent precautions, carries the risk of introducing Earth-based life to these pristine environments, potentially disrupting or even destroying any indigenous life that might exist. Conversely, there's the risk of extraterrestrial contamination, of bringing back unknown and potentially harmful organisms from other planets to Earth. These risks, while seemingly remote, highlight the need for careful consideration and international cooperation as we venture further into space. Section 9. Conclusion. Dreams deferred, not abandoned. The dream of colonizing other planets, of becoming a truly spacefaring species, remains a powerful and inspiring vision for humanity's future. But while our aspirations may be boundless, the reality of our current technological capabilities and the unforgiving nature of space dictate a more measured approach. The challenges of interstellar travel, of creating self-sustaining habitats on alien worlds, and of ensuring the long-term survival of humans in space are immense and complex. However, these challenges are not insurmountable. With continued investment in research and development, with international collaboration and a spirit of innovation, we may one day overcome these obstacles and turn the dream of space colonization into a reality. For now, the final frontier beckons, a testament to our enduring curiosity and our relentless pursuit of knowledge.